So you're going to want to pay attention as we go through all three of them. All right? Guys, this is serious. Next time I see you, which is Thursday, you're going to do another one by yourself. You're going to be on your own. So I need you focused and paying attention. Because the quiz on Thursday will not just be a verification. It will also have some other stuff in it because it's over 5-1 to 5-3. So you can expect some sum and difference stuff, some U plus V stuff. So we really need to pay attention and make good use of this time. So here we go. If you had number 1, your problem was this. That's what you had if you had number 1. Obviously, you gotta get rid of some stuff over here. So most of you noticed that you could factor the top. So factoring the top, taking out a sign, left you with 1 minus sine squared. And the minute you wrote 1 minus sine squared, your little heart starts palpitating because 1 minus sine squared is cosine squared. So now we have sine cosine squared over cosine. Right? Now, wait a minute. One of those is going to cancel with that, right? So I'm going to go ahead and cancel, and that's going to leave me with sine cosine.
Oh. And
now this is what I'm supposed to be ending up with. What do I know about cosine? It's the reciprocal of the secant. So I can write this because cosine is the reciprocal of the secant. So then I end up with sine over secant. So, if you had problem number 1 and didn't get it, there is a possible proof. If you didn't have problem number 1, I hope you're paying attention because the only way to get good at this is to practice it. Practice it, practice it, practice it. The problem you see on Thursday will be a problem you've never seen before. But you'll just need to deal with it using all these tools. All right. Problem number 2. Okay, it had a little more stuff. So problem number 2 is sine squared secant squared cosecant cotangent equals secant. Now obviously, again, we got way too much stuff over here. So I'm going to boil everything down to sines and cosines because hopefully if I do that, a bunch of stuff will cancel out. So sine squared, I'll put it over 1 because all these are going to be fractions. 1 over cosine squared, 1 over sine, cosine over sine. If I don't have my green sheet memorized, I'm dead in the water. I cannot proceed. You got to have your green sheet memorized. So I simply took all these random weird functions that have no relationship to each other and I changed them all into sines and cosines. Now what happens? Well, what do these two make? Sine squared, but I'll cancel with that. This is sine squared, that's sine squared, they cancel. That will cancel with this. And all I have left is 1 over cosine, which is secant. So if you had number 2, that is a possible solution. Possible proof.
good. Alright, big.
All right, and then the last one, number 3.
What is it? Johnny, it's okay.
Whoa. Immediately blocked us.
Okay.
So, go tangent.
Now, if you were astute, this denominator popped off the page at you. Because 1 plus tangent squared is secant squared. 1 plus tangent squared is secant squared. So I have cotangent secant over secant squared.
Immediately, that's cotangent over secant.
So now we can cancel. So we have cotangent over secant.
Yes.
Now, that isn't what we want. What we want is sines and cosines. So what's cotangent? Cosine over sine. And that is being divided by 1 over cosine?
So they got flip the switch.
With, yeah, flip and switch, whatever you want to call it. Yep, indeed. And what happens when you multiply by the reciprocal? You get cosine squared over sine. Now, listen. None of these involved anything tricky. Now, there were some tricky things you could do that made it faster, and a couple of you discovered those, and you did a great job. But none of these had to be done trickily. Just plain, straightforward, doing your green sheet identities, you can do it. Okay? So tomorrow, Thursday, we are going to have a quiz. And it's going to have one of these on it. That you're going to, it will not be a partner quiz. You will do it by yourself.
Same one?
All right? It's the
Same
same kind of problem.
It's not the same.
And then there will also be questions like on the practice quiz that we did yesterday. So the practice quiz we did yesterday, do you remember that? 5-1 to 5-3? Did we finish it? Somebody get it out. Did we finish it? I think we did.
Oh, yeah.
We did, yes.
We did, okay. So let me just throw a couple more problems up here that could potentially show up on tomorrow's quiz. How about for Thursday's quiz? The cosine of 295 degrees. The cosine of 295 degrees. What are you going to do with the cosine of 295 degrees? You're going to think of it as...
Oh, that's risky.
No. This is for it's got a bad problem up here. I got a bad problem.
285.
I went 285, yeah. 285.
That's the 45.
That is 45 plus 240.
Yeah.
Does anybody know what was wrong with the one I had up there before?
It didn't go 60 or 45 on that.
Exactly. Whatever, I could not break it up into things that added up using triangles with 45s, 30s, or 60s. So that was my fault. This one does. Because, what about 240?
That is 60.
240 has a reference angle of 60. So that triangle would look like that. Sophie, dear, you okay?
Yeah, there's something in my eye. I can't.
Do you need to go to the bathroom? The mirror works better than the iPad does.
Yeah, well, I have to sit with it.
I know you did. I appreciate that. Go ahead.
Feel better.
All right, and then 45, the other angle is 45, which we all know is 1 root 2, so we're good with that one. Please do pay attention to the negatives in the 240 angle, right? Okay, so now we're ready to start the problem. We figured out that 285 is these two added together. We could have used other angles, by the way, but these are kind of obvious. we drew our pictures of our 240 and our 45. Now what do we need to do?
Find the cosine.
No.
Cosine 45, cosine 240.
We have a formula for this. So John, it's not a matter of distributing. If you distribute, you get a big and no partial credit. It's just whack. The whole point is, we're supposed to be using those identities, sum and difference, u plus v, u plus v. So it's cosine of the first, cosine of the second, minus sine of the first, sine of the second.
You got it, bud. Sorry.
I need all the extraneous chat to stop. It's starting to stress me.
Sure.
Okay? I have to stay calm. All right, here we go. Let's fill in the blanks. What's the cosine of 45? Root 2 over 2. And in fact, so is the sine of 45, right? So I'll just go ahead and fill both of those in. Those are the easy ones. Now, look at your picture. What's the cosine of 240? Negative 1/2. What's the sine of 240? Negative root 3 over 2. So the answer to the question will be something over 4. My common denominator is 4.
Negative root 2.
Negative root 2.
Minus root 6.
Actually plus root 6 because it's minus a negative. Right? And have we seen answers that look like that before? Yeah, every time we do one of these, right? We get an answer that looks like that. Some combination of those numbers. Right, Jack? Okay. So I would anticipate that tomorrow, in addition to an identity, that you have something like this. Now, you might also have something like this tomorrow. Thursday. I know. The next time I see you, to me that's tomorrow. Now wait a minute. This is a no calculator quiz. There's nothing special about 123 and 12. What is going on here? What are you doing, Keyshawn?
Looking at beach house bungalows over here, Miss Ford.
What?
Looking at beach house bungalows over here.
Yeah.
Work backwards.
You're my bad.
Alright, I don't even know what beach house bungalows are, but it probably is not something you should be doing in math class.
Yeah,
Okay, what's going on here? Sine, cosine, minus cosine, sine. That should ring a bell. It's a sine formula. Is it the sine of a plus or a minus? Minus. In the sine formulas, the signs stay the same. S, 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 S. Now, what are my u and v? This is a formula for the sine of u minus v. So what do I have? 123 minus 12. So this is the sine of 111. What point am I trying to make? You need to not only be able to write the formulas out, but you need to be able to recognize them if they're already written out. Yes, go backwards. You have to be able to see them both ways. All right? Are we crystal clear on the expectation for Thursday?
So basically, if you give us one number, you want us to split it apart and use the formula, but if it's already split up for us, we just continue with it.
You put it together and give me one number. It's the opposite. Okay? Yes, that's exactly right. Now, this is going to require you to have your u plus v and u minus v formulas memorized because you're not going to have your green sheet with you tomorrow or Thursday. Okay? So if you haven't yet learned cosine, cosine, minus sine, sine, get it learned. Okay? Put it on flashcards, have your parents help you. Because what we're going to do today is continue our discussion. Did we start the double angles yesterday? Yes, we did. And we did just the doubles, though, not the halves, right?
Yep.
Does that right? So let me review a little bit. This is not on the quiz. This is the last part of this little unit. Your homework will be due Monday, and tomorrow or Thursday I'll tell you when your test is, but it will be probably the middle of next week because we're going to kind of finish up today. We still will spend one more day working on this, but I'm going to introduce the last part of the material today. Okay, so homework is due Monday. We'll be reviewing before then because your review assignment will be due shortly after that. So, here we go. Here we go. Let's review quickly what we learned yesterday. Suppose I said to you that the cosine of x was negative 3/4 and x was in quadrant 3. Find the sine of 2x. So this we talked about yesterday. This is not going to be on your quiz though because this is 5/4. So does anybody have any idea how we start this, Chandler? Draw a picture. All the time I'm going to draw a picture of my given. Whatever they give me, I'm going to draw a picture of it. Why do I hear this noise? I need you to stop it, all right? Please be respectful, okay? Of not just me, but of the people who are trying to learn. Okay. So I'm going to draw a picture of the angle in quadrant 3 whose cosine is negative 3/4. Now, does that look okay to everybody? Any questions about that? Please don't make the other side 5. It's not the hypotenuse. So you're going to have to do your Pythagorean theorem. So we have 9 plus b squared equals 16. So it'll be negative the square root of 7. Negative the square root of 7. Everybody get root 7 and everybody get negative. Okay. All right, what's the next step? Step 1, draw a picture of the given. Beautiful. I need another step though before I'm ready to go. What do I need to figure out? Find the formula that I am going to use. What is the formula for the sine of 2x? You may not have it memorized, and that's fine. Look on your green sheet. You need to have it memorized, Susan, but not right now. What is it? 2 times sine times cosine. So in other words, it's 2 times something times something. Where am I going to get these somethings? Where am I going to get these numbers? From my picture. So the sine is what? What's the sine? Negative root 7 over 4. What's my cosine? Negative 3 over 4. Now, let's not mess up the multiplication. These are 3 fractions multiplied straight across. So on top, I have 6 root 7. No, it will be positive because these are both negative, so that's going to be positive. And on the bottom, I have 16, which reduces to 3 radical 7 over 8. On the back, the double and half angles are on the back. This is a double angle formula. I'm doubling the angle. I'm doubling the angle. All right? All right, let's try one more. Let's suppose the given is this. All right, what do we do? Draw a picture of the given. So this time we're in quadrant 2, and the tangent, or excuse me, the cosecant is 5/2, so it would look like that. Now I'm going to do my Pythagorean theorem. Do not say root 29. 5 is the hypotenuse. So what is that second side going to be? Negative root 21. 25 minus 4, right? Do not get carried away and make dumb mistakes. All right, draw a picture of the given. Awesome. Then what? What formula am I going to use? The formula for tan 2x is 2 tan over 1 minus tan squared. That's on your green sheet, double angle tangent. Right, Griffin? So now what am I going to do? I'm going to take, I really only have to plug in the tangent. I'm going to figure out what the tangent is. Now that's kind of a mess. What is the tangent? 2 over negative root 21, which would be negative 2 root 21 over 21. That's what's getting plugged in. So here we go. 2 times negative 2 root 21 over 21 over 1 minus, all right, I'm going to cheat a little bit here. I need the tangent squared, right? So I'm going to come back to this step. What happens if that was the tangent. What happens when I square that? What do I get? I get positive 4 over 21. And that is a whole lot easier than squaring this. Would you agree with me? These are the same thing. I'm not allowed to have a radical in the bottom. That's why I did this. But if I'm squaring it, that radical is going to go away. So in this part of the formula, I'm just going to square that and have 4 over 21. Everybody okay with that? All right. All right, so now let's see. I'm going to take that times 2. So I have negative 4 root 21 over 21. I multiplied this times 2 over 1 minus 4 21s. Now you guys can handle that any way you want. I always handle mine by multiplying to clear the fraction. So I'm going to do it this way, but you can do it any way that's easiest for you. I'm going to multiply everything by 21 because that's easiest for me. And I'm going to end up then with negative 4 root 21 over 21 minus 4. Negative 4 root 21 over 17 is my final answer. Yeah, there's more arithmetic. There always is with the tangent. But all the time, the tangent formulas cause me more arithmetic. It just is. Okay, you alright with that? Alright, that's kind of what we did yesterday. Now I'm going to add the next layer, the last layer, and we're going to talk about the half angle identities. Okay? So here's how they work. Really, they're set up the same way. So maybe we say the cosine of x is 4/5, and x is in quadrant 4, and we want the sine of x over 2. Now, this is why it's called a half angle identity. It's x divided by 2. This one's called a double angle identity because it's 2 times x. That's how they got their names. It's pretty clear. All right, so what do we do? Exactly what you've already done. So we need a formula. Draw a picture of the given and write a formula. Okay, so what's the formula? Look on your sheet. What's the formula for the sine of x over 2? Plus or minus the square root of 1 minus cosine over 2. Now what's this look like? I'm in quadrant 4, and the cosine is 4/5. That's a nice one. That's one of my Pythagorean triples. There's my picture. Okay, now I'm going to plug my numbers in. Here we go. Things are going to get exciting here in a minute. So those of you that are trying to doze off, try to stay awake because it's going to get exciting. Woo! We're going to have to decide which of these we want. But first, let's take care of this. 1 minus the cosine. What's the cosine? 4/5 over 2. That's where I am at so far. Would everybody agree? Now, I don't care how you clean that up. Somehow you got to clean that up. I'm going to times everything by 5 because that's what I do. It's easiest for me. You can do it other ways. I couldn't care less as long as you get it cleaned up. This is going to be 5 minus 4 over 10, which is the square root of 1/10. What about the square root of 1/10?
That'd be 1/100. Oh, just kidding.
It'd be 1 over root 10,
Oh, yeah.
which is root 10 over 10. Everybody okay so far? Now, we have to decide whether we want the positive or the negative. It's not hard, but you have to stop a moment. Go back to the beginning. The original angle was in quadrant 4. That means it was between what? If it was in quadrant 4, it was between 270 and 360. Now that was given. You don't have to figure that out. That was given. Where is half of it going to be? Between what? 135 and 180. Now which quadrant is that? That's quadrant 2. You are looking for a sine of an angle that is in quadrant 2. What can you tell me about the sine of an angle in quadrant 2? It's a positive. Sine is y is positive in quadrant 2. So I'm going to choose the positive root. Do nothing for my self-esteem. This should be the highlight of your day. You've been waiting all day to come spend last period with me.
I am enjoying every second.
Thank you. All right, let's say the tangent is 5/12, and let's say negative 5/12,
Probably told me not to say that.
and let's put this one in quadrant 4. And let's find the cosine of x over 2. So this is essentially the same problem. We're just practicing one more time, going through our steps. Here we go. Yep, so we'll draw a picture of the given, which is the tangent is negative 5/12. Please make sure you get the negative on the right number. Is that okay? I'm putting it on the 5 like that. That's the 13 Pythagorean theorem. So there's my picture. Now I need my formula. What's my formula? Plus or minus the square root of 1 plus the cosine over 2. Smiley. So now I'm going to figure out what the cosine is from my picture. So the cosine is what?
That's 12.
What's the cosine?
13.
12 over 13. So 1 plus 12, 13, so over 2.
instead of over 13.
You know what I'm gonna do, times it all by 13.
So we got 13.
I'm so predictable, I'm gonna do the same way every time. So I have plus or minus the square root of 13 plus 12 over 26.
25 over 26.
So that's the square root of 25 26, which is 5 over root 26.
Yes.
Taking the square root of the top over the square root of the bottom. And then rationalizing plus or minus 5 root 26 over 26. Everybody clear with the arithmetic?
Yeah.
Because all that's left to do now is figure out if we want the positive or the negative.
Can we not leave it like 5 over 26?
Well, we don't want radicals in the bottom, remember?
Okay, yeah.
That's been kind of a common theme.
Yeah, I forgot.
Okay.
You didn't even learn it.
Alright, so original is in quadrant 4. Once again, that's between 270 and 360. That's quadrant 4. Go back to the original, set up your boundaries. Now we'll divide it all by 2. So the angle in the problem, which is x over 2, that's the angle we're doing, is between 135 and 180, which you already told me that's quadrant 2. So I am looking for a cosine of an angle that is sitting in quadrant 2. Cosine in quadrant 2 is negative. So this time we choose the negative. Wow. If you're looking for the tangent of a half angle? No, because it depends where the original angle is. If the original angle were in quadrant 4, this has been a tangent problem. In quadrant 2, the tangent's negative. Tangent's y over x. Remember, it doesn't even do with, well, the hypotenuse really doesn't. So it will be positive and negative different places, just like the rest of these guys are. Okay, now there's one more kind of problem we need to look at. So I'll pick one out of your homework for section 5.3. I think this is 5.3.
Look above you.
So you want me to pick 11?
Whole conversation that you had.
I don't think I've done 11 yet. Oh no, that's not 5.3. I'm going to 5.4. Oh gosh, there are so many awesome problems here.
Really?
So on section 5.4, which is page 475, I've already done number 5. Anybody have an assignment sheet? Did I assign number 7? Alright, I'm gonna do number 7 because I've already done 5 on some other video. So I'm gonna do number 7 for you. This is a different kind of problem. This is not one of those problems where we draw a picture and write the formula and plug stuff in. This is an equation that needs solving. Jack Linehan? Have we talked about Hulk moments? I'm about ready to have
So
one.
he's jacking around back there.
What's a Hulk moment?
Yeah, what's a Hulk mode?
Great reminder.
Yeah, we don't want you to get Hulk mode.
Yeah.
What's Hulk mode?
Yeah.
The Incredible Hulk, we talked about this.
No, I've never seen it. It was brought up on me.
Oh,
Yes.
they were on retreat.
Yeah.
Oh, they were on
It was about me.
cosine 2x equals sine x.
Basically, she told me.
There was a show on years and years and years ago, and I don't even know how it happened, but somehow he got ingested a chemical or got radiated or something, and every time he got angry, he turned into this huge green monster called the Incredible Hulk. So I told Braden that I didn't want to have a Hulk moment, and I was on the verge, and I'm getting ready to have one right now.
You should tell him to stop shaking.
All right, any ideas how we proceed with this problem?
Snakes is
I'm really
What?
set up a formula for
Exactly. We have a formula. Oh, wait a minute. We have 3 formulas for cosine 2x. Take a look at that list of formulas for cosine 2x and tell me which one, look at the whole problem, which one might be the best option. Look at the whole problem. I'm going to take this out and replace it with something. What might make the most sense? 1 minus 2 sine squared. And why does that one make the most sense? Because the problem already has a sine in it. We don't want problems to have cosines and sines. That's like having 2 variables, x's and y's, in the same equation. We want all the same. So when we have a choice, we're going to pick the one that keeps it all the same.
I think you're true.
All right, now I'm going to get this thing set equal to 0.
Factors.
And somebody is all over this, it factors. This is a quadratic equation. So I moved everything over to get it set equal to 0. That's a quadratic equation. Can you see how it factors? How does it factor?
Negative 2 and 1. Right.
So I'm going to have a 2 sine and a sine, and a +1 and a -1. Now, if you're just staring at that, you should be trying to FOIL it in your head. What do the outsides give you? 2 sine? What do the insides give you? -1 sine? What's 2 sine minus 1 sine? 1? So there it is factored. Remember when you were a little kid, you said, no, never got to factor. Well, yep, you got to factor everything factor. I mean, you have to factor your whole life. Now, what am I going to do with these 2 factors? I'm going to set them equal to 0 and solve. So would this one say sine equals 1/2? And this one says sine equals -1. Now we have to do them both. Which one would you like to do first?
1/2.
1/2, all right. Where does the sine equal 1/2? The directions, which I didn't write down, were this. That means we're going all the way around the circle, 0 to 2 pi. So look in the entire plane. Where could it be that the sine is 1/2? Certainly, the sine could be 1/2 in quadrant 1. Is there any place else?
3.
Not 3.
No.
2. 2. The sine is positive in 2. Couldn't the sine be positive 1/2 in quadrant 2?
Signs are positive both.
Yep. Sine is positive in both quadrants, and these directions tell me to look all the way around. Every quadrant. Now, if that's a 1, that's a 2, this is a 3. How big is this angle? 30. So my 2 answers are 30, that's that one. And what's the other one going to be? 150. So 30 and 150 are the answers to the first part. Okay? Now, what do I do with this?
Yeah, do it again.
I gotta do it again, but this is a little different. This is not a triangle. Think about it for a minute. Can opposite over hypotenuse be 1? No. No way. So it's on a circle.
It's on the
And,
bottom. Third
oh,
quadrant.
somebody said it's on the bottom. Why do you think it's on the bottom? That's where y is -1 and sine is y. So the other answer to the problem is 270. Y over r is -1 down at 270. Okie dokie. Quiz on Thursday, 5-1 to 5-3.
Class tomorrow?
No, we don't have class tomorrow.